Hello, and welcome to the composition of functions video. When we're talking about composition of functions, I like to think of it as the turducken of math. To remind you, turducken is a turkey with a duck inside of that, with a chicken inside of that. So it's just a bunch of birds wrapped in other birds. That's essentially what composition of functions is. It's just functions wrapped in other functions. So when we take a look right here at A of both problems 1 and 2, we read that aloud as G of F of 1. So whenever we see the parentheses there, we're going to think of F. So G of F of 1 with this F of 1 being the inside function. Now, for problem 2 down here, it looks a little different, that O in the middle. That is not a multiplication sign. If it's closed, then it's multiplication, but if it's open like that, that actually stands for the of. So we would also read this as G of F of 1 as well. So there is two different types of notation, all inside the parentheses or with that kind of open point there. And again, this is with F of 1 being the inside function. So what the G or the F and then of that number. So what that means is we'll take 1, we'll plug it into F, and we'll take whatever number that is and plug that into G. So we're just going to work on problem 1 for now, and then we'll move on to doing this symbolically. So if we take a look at problem 1, we have two tables, one for f of x and one for g of x. So like I said, we're going to start from the inside out. So we're going to start inside right here with f of 1. Well, f of 1, when our x value is 1, the y value for f of x is 4. So we have f of 1. But now we're going to take that f of 1, which is 4, that's inside of our g or our g of x. So instead of having an x, we're going to plug in this answer here of 4. So we'll have g of 4, and remember that 4 comes from this 4 right here. G of 4, when our x value is 4, y value for g is 5. So that's going to be our overall answer, that g of f of 1 is equal to 5. So we looked at our inside function, took that, plugged that into our outside function, and got our final answer. So let's try this again. So let's see, if we focus on g of 4, that's now our inside function, g of 4, so when our x value is 4, our y value for g is 5. We'll have that there. So that's our inside function. Now we're going to take that inside function, plug it into the outside function, which in this case is f. So we're going to look for f of 5. That 5 coming from right here. The only problem is that when I take a look at my x values for my f of x function, I don't see a 5. So I look back to my directions and it says evaluate the expression if possible. So it's possible we come across something that just doesn't work. So f of 5, not applicable, NA, or does not exist. So for our final answer for B, we're just going to say that there's no solution. Again, this doesn't mean that you've done the problem incorrectly. This just means we didn't get a final answer for this one, and that's okay. Now for part C, I see f of 3. I see the same function being plugged into itself, which is totally okay to do. So we're still going to start with that inside. Where's my highlighter? There we go. We're start with that inside of f of 3. Let's see, f of 3 is equal to, when the x value is 3, y value is 1. So it becomes 1. Now we're going to take that 1, and we're going to plug that into its outside function, which is still f. So we're going to have f of 1, with this 1 coming from right here. F of 1, when the x value is 1, the y value is 4. So we can say that overall that f of 3 is equal to 4. And there's my answer. Now, just a reminder for problem 2, we're not going to go over problem 2 right now, but for problem 2, these mean the same thing. So the second letter you have, that is your inside function. So this is f of g of 4. This is also f of g of 4. So I'd like you to keep that in mind. But this is how you do composition of functions with tables. Let's take a look at how we do composition of functions with equations. So if we move down just, oops, keep forgetting my settings. If we move down just a little bit, we come into 2 situations. I'm actually going to skip down to 4 before we get to 3 because I think it'll maybe explain a lot. So for 4, we're only going to do a right now. And a says f of g of x. And here's our f of x, here's our g of x. So we don't have a number to plug in, but I see that g is my, oops, sorry, that was not the highlighter. There we go. G is my inside function. So I'm going to take this g of x and put it inside my f of x. So this is going to look like, oops, that is still the highlighter. This is going to look like 3 of 5x, or probably 3 times 5x squared plus 4. So instead of plugging in a number, I'm plugging in all of my g of x into my f of x. So wherever I see an x, I'm going to plug in my whole function of g of x. But once we're here, we want to simplify the best that we can. Now, because this is an x and doesn't have a number, our final answer is not going to have a number. It's going to have an x in our final answer, and that's okay. So when I take a look here, I have to remind myself that this exponent comes before this multiplication. So I'm going to take 5x and square that. So I have to multiply the 5 by itself and the x by itself. So this is going to be 3 times 25x squared plus 4. And then I get to multiply in the 3 times the 25. And that's going to get us 75x squared plus 4. And that's as far as we can simplify down. So we have f of g of x is equal to 75x squared plus 4. And that's our final answer. So, going back to problem 3, there is a few different ways you can do this. We see that we have f of g of 4, so we're plugging in a number now. So you can either do kind of like the steps that we did here where you compose the functions first and then evaluate. So I can compose this f of x and this g of x and then plug in 4 to that. I, however, like to just find the inside stuff first, like with the number, and then plug in that number because I'm a little bit more used to that. So I'm going to start just finding my g of 4. So here's my g function. So I'm going to say that g of 4 is equal to 2 times 4 plus 1. So I'm plugging in that 4 wherever I see an x. I'm going to get 8 plus 1, or 9. So we've found our g of 4. Now, just like what we did with the table, I'm going to take this number and plug it in to my f function. So we're going to say that f of 9 is equal to 3 times 9 squared. And just a reminder, the 9 comes from our previous answer. So then we solve the best we can. Again, because there was a number inside here, we should end with a number as our final answer. The exponent comes before multiplication. So we're going to have 3 times 9 squared, or 81. And 3 times 81 gives us 243. So our final answer for this problem, oh, it's going to be a little squished, is f of g of 4 is equal to 243. Okay, I fit it in. So we can do that. So that is one method. Again, if you wanted to compose f of x and g of x first and then plug in 4, you can do that. But let's try part B. So part B looks a little different with that kind of open circle. Remember that also stands for of. So this is the same as g of f of -3. So those two things mean the same thing. We are going to go back and forth using different notation just to make sure you can read both of them. But if you prefer one over the other, you could feel free to always kind of move it to the other version. But we're always going to start with our inside function. So I'm going to start with this, f of -3. So let's see, f of -3, I'm going to take a -3, plug it into my f function. Just a reminder, when you're squaring something, you should always end up with a positive answer. So do parenthesis, -3 parenthesis squared in your calculator. But you're going to end up with 3 times 9, or 27. So once we've got this final answer, we're going to take this 27 and plug it into our g function. So we have g of 27 is equal to 2 times 27 plus 1, with the 27 coming from our previous answer that we're now plugging in. Let's see, our multiplication comes first, so 2 times 27 is going to be 54 plus 1, also known as 55 as our final answer. So we can say that g of f of -3 is equal to 55. Well, that one also got a little scrunchy. So this is how you might find composition of functions through equations or symbolically. I'm going to let us try the rest of these on our own, but let's see how we can use composition when graphing. So let's move onward. There we go. So we're going to do part A of number 5 when looking at the graph. I'm going to let you know right now, I already know I didn't give myself enough space, so I'm going to rewrite this over here. We've got f of g of 2, which remember is the same thing as f parenthesis g parenthesis 2, or f of g of 2. So we're always going to look at that inside function. In this case, g is our red function, so we're going to start with the red. So we'll have that g of 2 is equal to, let's see, that 2 is our x value. So when our x value is 2, our g function, that y value is -1. So we can say that g of 2 is -1. Now we're going to take this and plug this in to our f function, which in this case is still blue. So we'll have f of -1 with, again, the -1 coming from our previous answer. Let's see, f of -1. So when the x value is -1, the y value for f, that blue line, is at 1.5. That's exactly in the middle right there. We don't even have to guess. That's at 1.5. So we can say overall that f of g of 2 is equal to 1.5. So I think the biggest piece here is to make sure that you are keeping track of your functions graphs, just which graph goes to which equation, which we can see labeled here and here. I'll leave the other two pieces for the graph to go on your own, but what if we did this with ordered pairs? There's so many different ways you can do this. Well, using ordered pairs is kind of like using the tables. So given g of x is all of these points, which could be given in a table, and f of x is all of these points, which could be given in a table, find g of f of 2. Well, if we start with f of 2, it's saying, hey, when our x value is 2, what's our y value? Well, I see this point right here that says, hey, when our x value is 2, our y value is 1. Perfect. So we're going to take this and we're going to plug this in to our g function, g of 1, and see what we get. So I see, hey, when my x value is 1 for g, I see that my y value is in fact 2. So overall, we have g of f of 2 is equal to 2. Now, if you just showed me this, I'd be like, maybe you just guessed that. So please make sure when you're doing these problems that you are showing me all of your steps. So this is all that we have for composition of functions. If you'd like to pause here, you may do so. However, I do have a few problems at the end. Just going over functions again, because I know that I wasn't able to go over that with you on Wednesday because I didn't see you. So just want to go over a few problems about identifying functions, and we can spend more time talking about that tomorrow. So move this up a little bit. We come down here. Oh, look, we got graphs. We got ordered pairs. I love it. We're only going to do 3 of these problems together. So if we take a look at problem 1, we are determining if something is a function and explaining why or why not. So I look at this problem 1 and I go, hey, you know what? This is in fact a function. We're going to say yes with an exclamation point. And how do we know? Well, every x value has one y value. So we're a function. It's good. It's all you have to tell me. If we take a look at problem 2, which I think is slightly more interesting, and we maybe run our vertical line test. Oh, I'll get out my lightsaber. It's like, oh, this line perfectly lines up with a lightsaber. So not only does this x value have more than one y value, it has all the y values. So is this a function? No. And how do we know that? We can say the x value, I'm just going to say, has multiple y values. So you can list the number, or you can just say it has more than one, it has multiple. That works as well. Let's do one last problem with the ordered pairs. So let's take a look at problem number 5. It may be a little bit trickier here identifying if it's a function or not. Remember, every x value has to have exactly one y value. Well, if I take a look at number 5, I see, oh no, we have 1 right here, and we have 1 right here as my x value, but they have 2 different y values. So are these functions? No. I like to have the exclamation point. It makes me feel a little bit better. We can say the x value of 1, I'm getting specific here, has more than one y value. So hopefully that refreshes your memory just a bit of a few days ago, but I wanted to make sure I went over that. Let me know if you have any questions, and I look forward to seeing you tomorrow.